Okay, we're in section 40. It's the homework. We're going to do the homework. Um, and I'll do each problem separately, certainly. My goal here is to read the problem and follow the steps that are necessary in doing the problem. Certainly there is work down over here and someone says, well, that's just enough for me. That could be. I'm not saying it's not. Other students may need to watch me do the problems before they can attempt the problems. And that's fine too. All right, so I'll be doing all the problems one by one at the whiteboard. So let me switch over to the whiteboard and we'll finish these 5 problems. If a graph is being provided, I do suggest use the graph that's provided. So let me do another share with you. And give me a moment here. And let's see what we got here. Okay, so one problem at a time. And we're on the first problem, right? So let me just shrink this out a little bit. And certainly I want to read it to you. And what does it say? Use the shell method. Well, I have to know what the shell method is. And this is the section notes where we discuss the shell method. All right, I need to not only use shell method, be able to visualize a shell in the problem. And what I would suggest you do over here is, they have a region and they're going to rotate it about the y-axis. So the first thing I would suggest you do is kind of draw a rough picture of it. Now, before I do that, I want to see where these two functions intersect. So what I do is I set g of x equal to f of x. So g of x would be equal to f of x. And again, this is part of the visualization process. Well, a fairly simple problem because they're both linear equations. So you get 3x minus 10 is equal to 6 minus x. Now, if I solve for x, I get 4x. And let's see, if I add 10 to both sides, I get 16. And lo and behold, it's a pretty simple number. I get 4. So what I want to do is I know there's a point of intersection over here. And it occurs when x is 4. Now, if x is 4, those two functions should evaluate to the same number. But what number do they evaluate? 4, 2. All right. So what I want to do is I'm just going to push this over a little tiny bit. And I'm going to draw a picture now. Again, it doesn't have to be a great picture, but probably enough to get going. Now, x equals 0. What does that look like? It looks like this over here. That's x equals 0. All right. What else do I have to graph out? Well, I got to graph the point 4, 2 out. And let me do that for you. 4, 2 is going to be a point that's somewhere over here about. So I'm going to put 4, 2. All right. Now, what I'm going to do, I'm going to graph those two lines. And the first one I'm going to graph is just g of x. So it looks fairly easy to do. And that's going to be 6 minus x. So that's got an x-intercept at 6. So up here, so it's going to be 0, 6. And there's a line there that goes through that. Something like this over here. And I'm going to write down what that is. And that's going to be, y equals 6 minus x. All right, I got that. Let's do the other one. The other one's 3x minus 10. And minus 10, this roughly speaking is, I'm going to say that's 6. This would be like, minus 10. It doesn't be a great picture. It's just a point 0 minus 10. And what does it look like? It looks sort of like this over here. Oops. And what's that going to be? That's the line y equals 3x minus 10. And what's the region now? I'll shade it in for you. And this is the region over here, right? Let's shade that all in. All right, a rough picture. Now, what do I have to do? I have to rotate this about the y-axis. So let me just point out what that means. It's rotated like this over here. So I'm going to, put a shell down, and the shell I'm going to put down, the shell is going to look like this over here. All right, this is going to be a shell. And when it gets rotated around, it certainly looks like a can to me, or a can without a top or a bottom. And I'm going to just go through that with you. And so, if I took this thing over here, this shell, again, I'm not saying I'm the greatest artist, but sort of like this over here. All right, that's what that would look like. All right, to me anyway. What do? We cut it and we lay it flat. So if you laid that flat, it would look like a box then, right? Something like this over here. Now, again, a lot of students argue, do I need to be able to, visualize? Well, I'll be honest with you, it would be really hard to write the integral down unless you could visualize it. So I'm going to, do step by step. And the first thing I'll do is I'll put dx over here, and I'm seeing that. And I want to get the height of this thing. Right? What's that going to be? Well, it's going to be the upper curve, right? Which is this here, minus the lower curve, which is this here. All right. So what would you get over there? You'd get the height of that would be, let's see, it would be 6 minus x minus the lower curve, which is 3x minus 10. And if you simplify that, what would you get? You get 6 plus 10, which is 16, and minus x minus 3x would be minus 4x. All right. So I'm going to go over here and put the height down. And the height is 16 minus 4x. Whoops, sorry about that. And this thing over here, the thickness of that can is dx. What I don't have is the circumference of it. And the circumference is all the way around, right? That's the circumference. What's that going to be? Well, looking at it, it's going to be, this r over here is going to be the radius of the can. And what's the radius? It's just x. So the circumference is going to be what? 2 pi x. I can put the volume down now. And the volume of this thing is going to be, well, let's see. It's going to be, and again, this is 16 minus 4x, and the thickness is dx. That's going to be 2 pi x times, it's a box, it's pretty easy, 16 minus 4x, and then dx. All right, I'm just taking a representative box from this picture over here. What am I going to do now? Well, I got to integrate it over the x's. And someone says, well, what are the x's in the problem? Well, look at it. What are the x's going from? 0 over to this thing over here. And what's his position over here? It's the number 4. So I'm going to write that down. So the volume, this is the volume of a section. So I'll put this is this volume over here, and I'll call it section. And now I'm going to do the volume of the whole thing. So it goes from 0 to 4, 2 pi x, 16 minus 4x dx. Before you move forward, a lot of these problems, this is the part where most students really can't do this. And what they can't do is write down what the integration is. So, looking at it, I just want to make sure I got the right integration. And I'm really not there yet because I noticed they did some simplifications over here. So let me see if I can do the simplification now. So V, I'm going to factor it. And I notice there's a 4, so it's 8 pi. I pull that constant. And then what do I get? I get 4x minus x squared. Yes, it requires algebra skills. Let me point out what I did. 2 pi, I factored out a 4. That would mean that would be 4 minus x. Multiplied by x, you get 4x minus x squared. Fairly simple. Let me go back and look at it and see if I got that. And 4x minus x squared, yep, I got it. What's limits integration? 0 to 4, yep, I got that too. Let's write that down. Okay, so I'm going to say if the integration is not easy to do, don't do the integration. But this looks like a fairly trivial integration. I'd like to go through that with you. So you get 8 pi. The antiderivative is going to be 4x squared. Well, divide by 2, so 2x squared minus x cubed over 3. Limits of integration 0 to 4. Let's keep going. 8 pi. Well, I got to do this. And what are you going to get? Well, the upper limit, 2 times 16 minus, well, 4 cubed is 64, so 64 thirds, minus the lower limit, that's going to be 8 pi, and everything over there is going to be a 0 now, so that's fairly simple. Let's keep going because I want to see if I can match their answer. This is 8 pi, common denominator is 3. So what do you get? Well, you get 6 times 16 now, minus 64, all right? Now, if someone says the way you do arithmetic is really strange, it doesn't matter how I do arithmetic. We need to agree upon simple things. I'm actually going to factor out 16 from this problem. And a 3 from the bottom. And what am I left off with? 6 minus, what do you get over there? If you factor out 16 from 64, you get 4, right? And what do you get over here? V equals, I'm going to write this down now. It's going to be, let's see, 6 minus 4 is 2. And I'm going to do 2 times 8 is 16. So it's 16 squared times pi over 3. Now, if you're struggling with this, write it down, 16 squared, right? 10 times 16 is 160, and then 6 times 10 is 60, and 6 times 6 is 36. And when you get 6, 6, 12, 15, so you get 256. So it's 256 pi over 3, and this is going to be cubic units, all right? So what I'd recommend you do is just look back at your answer and see if that's what they have, and that's what they have, and you should feel good about getting those answers. All right, let's do the next one. And the next one is number 2. And these are more lengthy problems, there's no doubt about it. And I'm going to look at it, and it says use shell method, to find the solid obtained by rotating the region enclosed by the graphs. It says y equals x cubed. All right, this over here. I'm sorry, I said x cubed, it's x to the 8th. And the other one is going to be x equals 1/8. X to the 1/8, I'm sorry. So it's rotated about the y-axis. So I'm just going to make sure that you know. And if I can't remember what I read, I go back and read it. And this could be, I did it again. I'm sorry. It's y equals. Let me get my eraser out. I'm a little tired. And there's no excuse, by the way. You should always correct your mistakes. So where do they intersect? Well, let's write this down. They intersect when they're equal. So x to the 8th would equal x to the 1/8. And again, I'm hoping you're looking at that and you have some intuition about the solution to this problem over here without getting, too much work going. I'm just going to say certainly at 0, 0, that would be a solution to the problem. And what's the other solution to the problem? 1, 1. All right. So let's take a look. And I'm going to graph this out now. Again, I'm not going to say it's the best picture. And let's take a look. X to the 8th power, it's a rapidly growing polynomial, but I just got to go between 0, 0 and 1, 1. Now I'm going to be graphing in this guy first. And what's that going to look like? Sort of like this. All right. And then I'm going to graph in this guy next. And what's that going to look like? Again, I'm just doing it between those 2 points, something like this. What's the region now? I'm seeing it. And this is the region over here. Now remember, you can't remember what you've read. You go back and read it. But now I'm going to take a representative slice of this thing. And it's going to be rotated like this. And I think I'm ready to do this now. And I'll tell you why I'm ready to do this. First thing I would do is I would look at the differential. So what's a differential? I'm going to do vig. I'm going to write down pretty quickly now. So dx, all right? Now, if I rotate that thing around, I'm going to form a can. This is a shell method. And what's that radius going to be? Well, the radius of that can would simply just be the x value. And now all I got to do is the height of the can. And what's the height of that can? Well, I got to do the upper curve, which is x to the 1/8. That's the yellow curve, minus x to the 8th. What's my limits of integration? 0 to 1. I need to do the integration. V equals 2 pi, 0 to 1. We'll look at the answer key later. It's going to be x. I'm going to multiply it out because it's easier for me to do that to do the different, the antiderivative. And that's going to be, let's see, 9/8 minus, well, that's going to be x to the 9, right? Dx. I'm going to integrate. Again, we'll look at the key later. It's going to be an easy integration problem. 2 pi. Well, I got to add 1. That's going to be 17/8. Divide by 17/8 or multiply by 8/17 minus x to the 10 over 10. I want to repeat this to you. Mistakes are going to happen. If a mistake happen, please do try to correct it. Well, this looks pretty easy to do because 1's really easy to evaluate. And what do you get there? 8/17 minus 1/10 minus 2 pi. And the 0 is really easy to evaluate. It's just 0. All right, common denominator. Again, we'll look at the answer later. If I don't match the answer, I'll redo the problem or look for my error. And what do you get there? 170, common denominator. You would get 80 minus 17. Let's keep going. V equals, well, I'm going to reduce it. And the reason for that, I notice that 2 goes into 170, and that goes into 85 times. Now I get a pi. And what's 80 minus 17? Well, that's going to be 63, right? And what do you get? 63 pi over 85. All right, again, we're going to repeat this. If I make a mistake, I'm going to correct it. Wow, look at that. 63 pi over 85. It's right over here. All right, that's a typical way to do a homework problem. Again, you can look at my work if you want. You should see some similarities between my work and what we just did. All right, the only difference is I'm not putting a graph down. All right, I'm going to the next one, problem number 3. And again, I'm looking at it, and my goal here is to, try to understand the problem. And it says use the shell method. Well, this is all about shell method now. And I got 2 functions. I'll try to graph those out for you. And they're relatively simple functions to graph. And what's it going to be? Y equals x squared. And the other function's y equals 32 minus x squared. So the first thing I would like to do is just find the point of intersection by setting them equal. So x squared would equal 32 minus x squared. I would add x squared to both sides. That would give me 2x squared equals 32. I would divide through by 2. I would get 16. And what do I get over here? I would get x equals plus or minus 4. So I got 2 points of intersection. And that would be, 4, 16. You can check that if you like. And minus 4, 16. Right? 2 points. I'm going to draw a picture. I'm not going to say it's going to be the best picture, but I need to visualize. And what am I visualizing? The first thing is I see a parabola that looks like this over here. And this is the parabola y equals x squared. That's done. The other one's 32 minus x squared. And I got to be honest with you, the picture doesn't have to be great, but I'm going to say maybe something like this over here. And that's good. This is the, y equals 32 minus x squared. All right. Do I know these 2 points over here? I certainly do. This is not being drawn to scale, but it's enough for me to, visualize what I need to do. And this point over here is 416. This point up here is going to be 0, 32. This point over here is going to be minus 4, 16. And I'll be honest with you, it's really a sloppy looking picture. There's no doubt about it. What's the area I'm looking at? Yeah, the area, it's a region. I'm looking at this area here. All right. Now, if you don't read, by the way, I got to be honest with you, you're really tough to answer the question if you're not willing to read. But what do they say? X is greater than or equal to 1 now. And I'm going to put that down for you now. So if x is greater than or equal to 1, I'm going to put the line where x is 1. Let me put that down in a solid color. And this is the line x equals 1. And what is it? X is greater than 1. So now they're talking about this region here. All right, I see that region. Right, x is greater than 1. And what are we going to do? Rotate about the y-axis. So this thing is being rotated like this now. Well, I'm going to do the same thing. I'm going to draw my representative section over here. I'm going to rotate that. And I'm kind of ready to write it down. And I really mean that. And I'm going to write down, first thing I write down is the differential. So I'm going to do the volume. And the differential is dx. 2 pi x. Again, the radius of that is x. Upper minus lower. What's the upper? Again, if you can't remember, maybe look at your picture, but it's 32 minus x squared minus the lower, which is minus x squared. And what's the limits of integration? Well, the x starts at 1 and it stops at 4. Fairly easy if you can visualize the problem. I'm going to kind of work through the steps now. I want to see if I get their answer. That's my goal. I'm going to put 2 pi, factor in a constant. And what do you get there? 1 to 4. And, looking on the inside, it's 32, right? So it's going to be 32x. And then minus 2x squared, right? Times x is minus 2x cubed. All right, I'm going to say it again and again. Mistakes happen. And this is why you need to look at a key, right? I make mistakes too. I look at keys as well. And by the way, a lot of people look at the key and say, oh, the key must be wrong. It could be. I'm not saying it's not. It's unlikely though. All right. It does happen though. Right. If you think there's an error in the notes, please bring it to my attention. All right, what do you get over here? Well, 32x squared divided by 2 would be 16x squared. Then when you go over here, well, you'd get, x4, and I divide by 4, so it'd be a half. And what's limit integration 1 to 4? Right, let's keep writing it down. This is 2 pi. Well, the 4 is a little bit difficult, but I'll be honest with you, I think I just did it before, right? 16 times 16 is 256. Minus, well, the fourth power of 4, 4 times 4 is 16. It's 256. We'll do that later. Minus 2 pi, and this would be 16 minus 1 half. All right, I'm going to keep going step by step. And we'll look at the key later. Well, this is 256 minus 128. Well, I'm going to multiply this one out, and this is going to give me minus 32 pi. And what do you get over there? Plus pi. All right, let's keep going. V equals 2 pi times 128. Again, if you don't like the way I'm doing arithmetic, you do your own arithmetic, but we can't disagree upon it. Right? If we're getting like 7 and I'm getting 2, there's got to be someone's got to be wrong. All right, we could both be wrong. All right, what's minus 32 plus pi minus 31? All right, let's keep going. 256 pi minus 31 pi. And what do you get over there? Let's see, 2, 2, 5 pi. And they're cubic units, by the way. Let's look back. And I think I made a mistake. What number are we doing? Oh, I'm sorry. We're doing number 3. I was looking at number 4. That's why I thought I made a mistake. So 225 pi. Geez, we got that one right too. And I really mean that. A lot of times you're going to be shocked to get something right. All right, let's go to number 4. And number 4 says use the shell method. And I have to, visualize. I have to visualize. And I'm going to visualize. I'm going to visualize by the point of intersection first. And I'm going to say y equals 8 minus x cubed. And the other y is y equals 8 minus 4x. I want to encourage you, we give you problems that are really doable. I'll set these equal. I want to find out the x value that makes them equal. So 8 minus x cubed equals 8 minus 4x. I'm hoping it's going to be really simple to do, by the way. Subtract 8 from both sides. And what do you get? Minus x cubed minus 4x. I surely know a bunch of solutions to that, but I want to go through the work with you. And I would set it equal to 0. You would get x cubed minus 4x. I would factor it. X comes out, you get x squared minus 4. And I think I can write the answers down. Now, so 0. So if x is 0, what would y be? 8. That's a point of intersection. What's the next point of intersection? At plus or minus 2. I put down 2 first. And what would you get? 0. And if you put down minus 2, what would you get? Let's see. Minus 2 would give you 16. Okay, I got 3 points of intersection. Hey, again, someone says, I don't want to graph it. I just want to write down the integration. If you can, you can. Some people can visualize things in their head. I'm going to point out most people can't. All right. So I'm going to try to, move this over a little bit. I'm going to try to visualize. And I'm going to visualize one thing at a time. 0, 8. I'm going to say it's over here somewhere. I'll write that down for you. And then 2, 0. I'll say it's over here somewhere. And then minus 2, 16. I'm going to say that's up here somewhere. Whoops, sorry about that. Okay, let's put the line in. And the line looks like this here. Again, I'm not saying I'm doing a great picture. I'm really not. And that's my line. And then 8 minus x cubed, right? Well, that could be a little difficult, right? So I know it's a cubic. And I'm going to say, looking at it, I know it goes through those 3 points over there. I'm going to say something like, let's see what it's going to look like over here. Maybe something like this. All right, that's a little kind of rough graph, isn't it? So I'm wondering what region they want. I got to go back and read it to you. And it says, use the shell method to compute the volume rotating region closed by the graph. Oh, they say x is greater than 0. So now I got a region over here. Put this over here. I'm going to shade it in for you. This is the region. All right. So let's go through it. And I'm ready to write the volume down. But before I do that, I want to write that representative region down. And it's this guy over here. It's going to be shell method. How are we going to rotate it? I got to read it. I didn't read that part about the y-axis. All right, let's write this down. So the volume is going to be, let's see, I'm going to start at 0, go to 2. I'm going along the x-axis. That's a differential. 2 pi x. X is the radius of that can. Upper minus lower. What's the upper? It's that cubic function, which is 8 minus x cubed minus the lower. What's the lower function? 8 minus 4x. So it's going to be 8 plus 4x. Okay, let's keep moving. And I'm going to do the integration now. So 2 pi, 0 to 2. The 8's disappear. And you're going to get 4x squared. Again, you need algebra skills to do this. So the 8 disappeared because 8 minus 8 is nothing. Then I get 4x squared minus x to the 4th power dx. Let's keep moving forward. Again, I know I say this a lot to you. If you make a mistake, you need to correct those mistakes. Now, you don't want to make mistakes on exams, but it does happen. And certainly when you get an exam back and there's mistakes on it, you should correct those too. Number 3 minus x5 over 5. And we're going from 0 to 2. Let's write this down. V equals 2 pi. And I'm going to get 4. 2 cubed is 8. Minus, well, 2 cubed is 32 over 5. Minus, well, it's going to be a 0, right? If you look at it, you plug in a 0, you get a 0 there. 2 pi times 0 is still 0. So V equals, common denominator 15, 2 pi. Let's see, you would get 20 times 8, 160. Minus, and 3 times 32 would be 96. And yeah, I know it's annoying to do arithmetic, but you have to learn arithmetic certainly if you want to move forward. 160 minus 96 is going to be 64, right? And what's that going to give me? Well, 2 times 64 is 128 over 15. It's annoying sometimes when you get an answer, it's a wrong answer. You can say, oh, what do I do now? Well, part of this is your learning exercise. You really want to be able to get these answers. And I got that one right too. All right, I got it. This is good. Let's go to number 5. Number 5 gives me a picture. And so what I'm going to do is I'm going to use the picture. I'm going to take this and I'm going to copy it. And I'm going to look at the picture. And then I'll come back here and look at the answer. So I'm going to the next page. And I'm going to paste that in. Give me 1 second. And I'm going to do it. And I'm glad they gave me a picture. I'm going to use that picture. All right, just going to use it. So first thing I'm going to do is just, look at the picture. Let me pull this over here. I'm going to look at the picture, blow this up a little bit, and kind of label the picture for you. And I'm seeing a bunch of curves in that picture. It'd be nice if I could recognize the curves, and I can. And I'll outline this for you. This picture here, and I'll just put this down over here, is this parabola here. All right, I'm looking at it. And the cubic is this guy right over here. And I'm looking at it, and x equals 3. That's really easy. That's right over here. Really easy. What do they want to do? They want to rotate this to line x equals 5. This to line x equals 5. So I'm going to try to do it. All right. And suppose, I don't think I can do it. You can do it if you try. You may not get it in your first try, but it's this region here that I'm going to rotate about this thing over here. All right. So let's take a look at it. And I'm going to write down, what I like to write down. I like to write the differential down. So I'm going to say V equals, well, let's write this down. My x's are moving from, well, maybe I should put those points of intersection down for you. And it looks pretty obvious over here. This looks like 1. Let's see if that's true, though. Is that 1? Well, the first equation, get x cubed plus 7, if that's 1, that would give me 8. And the other one's 9 minus 1. Well, that's 8 too. Well, that's pretty reasonable. Picture's good. So I'm going to go from 1 up to that, that green line, which is 3. 2 pi. And this is where most people put x down and not really thinking. And what I got to get across to you is that the radius of this problem, this is the radius. And what's radius going to be? Well, upper minus lower. What's the upper? It's 5. Minus the lower. What's the lower? It's the x value between 1 and 3. All right. Now, what's the height? That should be easy. Times the height. It's upper. That's the red curve, which is x cubed plus 7 minus the lower, which is the blue curve. And the blue curve is going to be 9 minus x squared. So minus 9 plus x squared and dx. Now, granted, these numbers look a little bit nasty, but let's go through it. All right. You might have to use a calculator. I don't know. So I can put the 2 pi out. 1 to 3. All right. And I get 5 minus x. It's going to be the toughest problem in the set. This is typical. Problems get more difficult as we move forward. And what do you get there? X cubed plus x squared. All right. And 7 minus 9 is minus 2 dx. I'm going to continue to simplify the integrand. 1 to 3. And I'm going to do that on the side for you. So I'm going to do this 5 times that. So it's 5x cubed. This is side work. Plus 5x squared minus 10. And I'm going to multiply by minus x. So minus x4, write this over here. Wait a second. Yeah, I'm sorry, minus x4. And then let's see, minus x cubed plus 2x. Let me see if I did that right. 5x cubed, 5x squared, minus 10. And then minus x4, minus x cubed plus 2x. Let's write this down. And what do you get? Well, it looks pretty complicated. Let's write this down. Minus x4. That's this guy right over here. And I'll do these guys. It's going to be plus 4x cubed. Then I got plus 5x squared. It's nasty, isn't it? And then I got plus 2x. And I got a minus 10 and dx. I understand making mistakes too. I really do. It's if you make a mistake and not doing the problem, that's probably the biggest mistake people make. They say this is just too much work for them. And what do you get over here? Minus x5 over 5 plus 4x4. Well, that would just be over 4, which would be just x4. This would be 5x cubed over 3 plus x squared minus 10x. Well, that's pretty nasty, isn't it? Limit integration 1 to 3. All right, so V 2 pi minus 3 to the 5th power. I'll do that later. Plus 3 to the 4th power. I'll do that later. 5 times 3 cubed over 3. I'll do that later. 3 squared, which is 9, minus 30. All right, let's keep moving. I know it's tough. Minus 2 pi. Well, the 1's easy. minus 1/5 plus 1 plus 5/3 plus 1 minus 10. Right? Don't be discouraged. I think I want to do that second term first. Common denominator 15, right? Let's write this down. Minus 3 plus 15 plus 25 plus 15 minus 150. Let's see if I did that right. 15 minus 3, 15, 25, 15 minus 150. Let's add them together. 15, 25, and 15. That's 30, 40, 55. So that would be minus 95, minus 98. Yep, it's work, man. It is. It's going to be plus, let's see, what's 2 times 98? 180, 16, 196 pi over 15. If you thought that was tough, what do you see the other guy? Well, the other guy, I'm going to do some work. And I really have to do work. I kid you not. And someone says, why can't you just do it in your head? I really can't do that. I'm going to do this over here. 3 to the 4th power. 3 times 3 is 9. 81 plus 9 minus 30. And what do you get up there? That would be 90, 60, right? I'll just simply say 60. Again, I did 81 plus 9. That's 90 minus 30, 60. That wasn't so bad. I'm going to do this one now too. I don't think it's that bad. I always go for easy things. What do you get there? You get actually 5 times 9, which is 45. That's going to be 105 now. I got the killer. Right, I got a killer over here. So what do I got? Let's see. Minus 3 to the 5th power. That's 81 times 3, 243. Over 5 plus 105. I got more arithmetic to do. Minus 243 over 5. That'll be 525, right? Wow, this is going to be really tough. Let's write this down. That's going to be 2, 8, 282. Wow. I got to multiply by 2 pi now. Get back by black ink. So 2 pi times that would be what? 4, 160, 564. This pi. Wow, I got to do more arithmetic. Common denominator is 15. By the way, I understand making mistakes in arithmetic. I really do. I don't enjoy arithmetic either. And 3 times, oh boy, 564. Well, 1500, 180, 1680, 1692. I got to write this down. 1692, 196, 8, 99 is 18, 678, 1888. Take a look. I think I might have made a mistake somewhere though. Oh, I got to go back to the other page now. Whoops, sorry about that. I didn't mean to do that. I think I blocked something there. I got to pull this around. You know what? I think I blocked it. I can't seem to move it anymore. I can move that around. I can move this around. Why am I having a tough time moving that? You know what I got to do? I got to go back to my notes. And I'll look out of my notes here. Oh, it's on the prior page. That's why I can't move it. 1888 pi over 15. What did I write down? Wow, we got that one right too. Miracle. We did some good arithmetic there. Thank you for your attention.